What type of attire can employees wear when working with machines? What type of attire should they not wear? Wearing the proper attire or clothing is very important when operating machines or working around them. Loose clothing, jewelry, and long hair can get caught in a machine, causing injury or death to the employee. Always follow these clothing safety guidelines when operating or working around machines. Eye protection. Wear properly fitting, approved safety glasses with side shields. Machines such as drill presses can produce flying chips that can damage eyes. Hair. Tie back long hair or tuck it into your shirt or hat. Clothing. Wear close-fitting clothes. Footwear. Wear proper shoes to protect your feet. Depending on plant policy, this may be heavy-duty leather shoes or steel-toed shoes. Canvas shoes are usually not acceptable. Jewelry. Remove ties, rings, watches, and other jewelry. Gloves. Do not wear gloves around a machine that rotates or has heavy moving parts. If the environment requires gloves for some other reason, such as sharp edges, chemicals, or temperature, wear tight, form-fitting gloves of a type chosen to reduce the risk of entanglement. Before starting up or operating a machine, it is very important to learn about the machine. Make sure you know how the machine works, its operating procedures, key safety points, and how to safely shut it down. The steps you can take to learn your machine include: read the machine's operator manual, read the machine's standard operation procedures, and observe a skilled operator operate the machine. Before starting up a machine, always inspect the machine to make sure it is ready to operate. An inspection should include walking around the machine to make sure all guards are present and operational. No loose parts are near the machine, adjustments are correct, and fluid levels are normal. If you find a problem, such as a machine safety guard bypassed, immediately lock out, tag out, and test the machine to ensure that no other employee can use it, and then notify a supervisor. An employee who fails to test a machine after lockout tagout should be retrained. Another important step to perform before starting up a machine is to check the tooling and the workpiece. Never use a damaged or worn tool. Tools that are damaged or worn could cause an injury or poor work quality. Also, make sure your workpiece, the part the machine will produce, is loaded in the machine and properly clamped. Machines that have a continuous feed of material should be checked to make sure the material is loaded properly and there is enough supply. If the workpiece material is heavy, always make sure to use a lifting device or get someone else to help you. If you lift without assistance, always use proper lifting technique by bending at your knees and keeping your back straight. Once the pre-startup steps have been performed, the machine is ready to start up. The first step is to turn on power. Only the operator should turn the machine on. The operator is the person responsible for knowing if the machine is safe and ready for use. Observe the machine and the operator display for any abnormal messages or actions. After powering on, some machines require additional adjustments, such as setting 0 points or speeds, before being put into operation. Make these adjustments before operating the machine. Make sure the machine is safe to operate. Do not operate machinery if a known safety problem exists. Notify your supervisor immediately of the problem. Operating procedures vary by machine. Always follow the standard operating procedures, or SOP, for your machine to operate it. Even the most automated machine should be monitored to make sure they are operating properly. This requires attention from the operator at all times. Do not allow others to distract you while operating the machine. The easiest way to injure yourself is to not pay attention. Make sure you know how to shut the machine down after normal operation and how to shut it down in an emergency. Machines use different stop methods to perform stops in various situations. Operator stations are often equipped with a separate emergency stop push button, pause or halt push button, and cycle stop push button, emergency stop push button, cycle stop push button, and halt push button. The emergency stop push button, or e-stop, is used to stop the machine if there is a machine malfunction or safety issue. The e-stop removes power to parts or all of the machine and requires a complete power-up procedure to restart. The cycle stop push button stops the machine after it completes the workpiece currently in production. The machine remains on. Production can continue when the start button is pushed. Cycle stop is the button you would press to stop the machine at the end of a shift or to stop to reload material. The halt push button, sometimes called pause, stops the machine in mid-cycle after it completes its current step. This button is used when the machine needs to be stopped, but with the ability to continue the cycle by pressing the start button or resume button. Identify the machine operator safety violations in the scenarios shown. What is wrong here? What is wrong here? What is wrong here? What is wrong here? A machine guard is a device that is designed to keep the operator and others clear of dangerous machine parts, especially moving parts, while it is in operation. There are 4 major types of guards: fixed guard, removable guard with interlock, adjustable guard, and self-adjusting guard. A fixed guard is one that is permanently mounted to the machine. It is normally used on the parts of machines that do not often need to be accessed for servicing. Removable guards are designed to allow the workpiece to enter or exit the machine or to make adjustments. These guards are commonly interlocked with some kind of electrical or mechanical device to prevent operation if the guard is not in place. These guards are designed to be used where a worker needs access to the guarded area to remove parts or add material. An adjustable guard is one that can be customized by the operator to accept various sizes of stock while still protecting the worker from the point of operation. This guard is often found on different types of saws. A self-adjusting guard is one that automatically adjusts to the size of workpiece being machined. It automatically pushes away from the point of operation enough for the operation to be performed while still protecting the employee from harm. This type of guard is normally used on saws. A machine interlock prevents a machine from operating without the proper guards in place. The interlock may be either mechanical or electrical. A mechanical interlock is a device that uses physical means to prevent operation unless guards are in place. The guard acts as a sort of key that unlocks the machine for use. When the guard is in place, the mechanical device moves to engage the machine's moving components, allowing the machine to operate. Mechanical interlocks are also used as physical operator restraints. An operator restraint prevents the operator from being in harm's way while the machine is operating. There are two types of physical restraints that are commonly used: pullback restraint and holdback restraint. The pullback type restraint consists of cables attached to the operator's body that pull the operator's arm back from the machine when the machine is in the potentially dangerous part of its cycle. A holdback type restraint consists of cables that restrain the operator's arm from entering the machine at any time during operation. An electrical interlock uses an electrical switch or electronic sensor to prevent machine operation when the guards are not in place. When the guard is in place, it activates the switch. One example is a CNC machine with an interlocked door sensor. When the door is opened, the sensor automatically stops the machine to prevent it from operating. Operation will not start or resume until the door is shut again. There are many types of emergency stop controls. All of them are designed to shut down a machine immediately if the operator is in danger. Some types of emergency stop controls are presence sensing restraints, physical restraints, and electromechanical restraints. Presence-sensing emergency stops allow or prevent a machine from operating when an operator is present. One type is a photoelectric emergency stop, also called a light curtain. A light curtain is a type of electrical interlock that is a guard in itself. This system most often uses several low-power laser beams arranged in vertical rows like a fence that surround the machine operation area. If the operator steps or reaches across the beams, a signal is sent to the machine's controller to stop or shut down the machine. Some examples of electromechanical emergency stops are safety trip, emergency stop push button, and gate. A safety trip control is essentially a sensitive button attached to a trip rod or bar which is placed on the machine. If an operator is forced toward the machine or working inside the machine, the button or bar will prevent the machine's operation. An emergency stop button is normally a red, mushroom head button that is designed to be highly visible so the operator can quickly locate it. Once pressed, the push button remains pushed in until the operator pulls it out. The emergency stop removes all power to the equipment. It overrides all other machine functions and operating modes. The gate is a physical barrier that prevents the operator from reaching into a machine during operation. A gate uses a sensor that interlocks it to the power so that it must be in place before the machine will operate. When the gate is in place, it is impossible for the operator to reach into the machine. One of the greatest dangers in a facility is for an employee to power up a machine while it is being serviced by another employee. Interrupting the power source is the safest way to lock out machines. To prevent this, OSHA requires all power sources that can be locked out are locked out during servicing. The procedure used is called lockout tagout. OSHA requires all companies to develop a lockout tagout procedure and to train employees on the procedure. Why are lockout tagout procedures critical to effective communication in a facility? What could happen if the procedure is not followed? OSHA requires lockout tagout to be used with all sources of dangerous energy. Dangerous sources can include hydraulics, steam, compressed air, mechanical, and electrical. All electricity of any voltage should be locked out before working on the equipment. Lockout tagout consists of two parts: lockout and tagout. Tagout involves placing a tag on the power source that warns others not to restore power. The tag should clearly state, "Do not operate," or another similar statement. In cases where the power source cannot be physically locked out, the tagout may still be used. To perform a lockout, a lock is attached to the power source so that the power cannot be turned on. The lockout process ensures that the energy flow from the power source to a machine remains blocked. This is most often done by attaching the lock to a bracket-like device that prevents the power switch from moving to the on position. An electrical lockout tagout system has three main components: lock, lockout hasp, and tag. The procedure to install a lockout tagout consists of 5 steps. Step 1, shut down equipment. Step 2, connect hasp. Step 3, attach lock. Step 4, add tag. And Step 5, test start equipment. If an employee is observed incorrectly performing a lockout tagout procedure, the employee should be retrained on the procedure. Step 1, shut down equipment. If the equipment to be locked out is operating, use the normal procedure. For example, stop push button or selector switch to stop it. Then turn off the main power switch to the equipment to be locked out. Many machines are wired to a separate power switch called a safety disconnect switch. This switch is often mounted separately from the machine and totally removes power from the machine. Interrupting the power circuit at the motor disconnect is the only reliable way to lock out a motor. Step 2, connect hasp. To perform a lockout tagout on an electrical system, first make sure the power switch is in the off position, and then connect the hasp to the power switch bracket. The lockout hasp uses a scissors action to hook through the holes in the bracket. This prevents the power switch from being placed in the on position. Step 3, attach lock. Once the hasp is fully closed and the holes are aligned, attach the lock to one of the holes in the hasp. This prevents the hasp from being opened while the lock is in place. Step 4, add tag. Before the lock is closed, a tag is added to identify the lock's owner and the date the lockout was performed. Step 5, test start equipment. Before starting work on locked out equipment, test the equipment to verify that all dangerous forms of energy have been removed. To test for dangerous energy, make sure pressure gauges read 0. Attempt to operate the equipment by pressing operator start buttons. Make sure indicator lights are all off. Standard operating procedures should specify all tests to perform. Companies should use a one-person, one-lock system for lockout tagout. When more than one employee is servicing a machine, each person should install his or her lock to the lockout hasp. A common hasp has holes for 5 locks. The 6th hole is used to install another lockout hasp to ensure that there are always available holes for additional locks. Some small machines and power tools are connected to power by a power cord that connects to a wall outlet, rather than being hardwired to a main power switch. To lock out machines that use a power cord, a lockout plug is used. A lockout plug completely encloses the plug, preventing it from being plugged into the wall outlet. A lockout tagout is then applied to the lockout plug. When performing an electrical lockout tagout, the last step the employee should perform is to test the machine to make sure power is completely off. The only person who should remove a lockout tagout is the person who installed it. In a case where there may be several people servicing a piece of equipment, a multiple lockout is used. Each person must attach their own lock, so the machine cannot be turned on until everyone has removed their lock. If the person who installed the lockout tagout is not available, it should only be removed after following the steps to remove a lockout without the installer. If the person who installed the lockout tagout is not available, the following steps must be completed before the device is removed and before the installer returns to work. Employer has verified the employee is not at work. Employer has made all reasonable efforts to contact the employee to inform them their lockout tagout is being removed. Employer has informed the employee that their lockout device has been removed before they can return to work. Perform a lockout tagout on this system so that it is ready for servicing or maintenance.